Hello students, hope you are enjoying my video lectures. After this lecture, you will be able to explain linear charge distribution, surface charge distribution and volume charge distribution. So far we have discussed the electric forces and electric fields due to point charges or system of point charges. It makes our calculation simpler and it does not involve any calculus. But if we consider that the charge is distributed over the length of a conducting wire, if we consider a conducting surface and charge is distributed on the surface of it, if we consider that the charge is distributed throughout the volume of a sphere, then the discontinuous charge distribution in the microscopic level can be ignored, and we may consider that the charge is distributed in a continuous manner. Then we are actually considering continuous charge distribution along the length of a wire on the surface of any conductor, or it may be throughout the volume of some sphere. So accordingly, we have three different types of charge distribution. One is known as linear charge distribution. This is also one-dimensional charge distribution. If we consider second category, this is surface charge distribution. That is actually two-dimensional charge distribution. And you can also have volume charge distribution. That means three-dimensional charge distribution. So you also have three different charge densities. Okay, we are considering one by one. So let us now first concentrate into linear charge distribution. We may consider a conducting wire over which charge is distributed. The length of this wire to be equal to L. I consider a small element as dl, and I want to find out the force acting between this wire and this point charge Q0. Let this Q0 be at a distance r from this dl. I also consider that this dl contains dq amount of charge. When we consider linear charge distribution, we may define linear charge density as lambda. This lambda is equal to charge per unit length. This can be termed as dq dl. So from this I can easily write dq is equal to lambda into dl. So you can easily write dq is equal to lambda into dl. If I want to calculate the mutual force between this dl and q0, or if I consider the force experienced by this q0 due to this element dl to be equal to df, then according to Coulomb's law, I can write 1 by 4 pi epsilon 0 q0 dq by r square into r cap, where I consider that r cap is the unit vector along r. I can substitute this value. So I have 1 by 4 pi epsilon 0 q0 into lambda dl by r square into r cap. So if I now want to calculate the total force acting on q0 due to this entire length of this wire, I have to integrate this over this length L. So I can write F is equal to integration over df, that means integration over length 1 by 4 pi epsilon 0 q0 lambda dl by r square into r cap. So you can take 1 by 4 pi epsilon 0 common, you can take q0 common, integration over L lambda dl by r square into r cap. If this lambda remains constant throughout this length, you can also take lambda common. But if this lambda is not constant throughout this length, I cannot take this lambda common. So I have to write the expression for force on q0 due to this entire length is equal to 1 by 4 pi epsilon 0 q0 integration over L lambda dl by r square into r cap. Similarly, you can calculate the electric field at the point P due to this entire charged wire. I can write it as F by q0, that is equal to 1 by 4 pi epsilon 0 L lambda dl by r square into r cap. Okay, so this is how we can obtain expressions for force and electric field due to linear charge distribution. Next we consider surface charge distribution. We consider a surface over which charge is distributed. Now we consider a small portion of this surface, let it be ds, and this entire surface may be represented by S. This ds contains dq amount of charge. I want to find out force experienced by q0 charge, which is at a distance r from this surface element ds. We also consider unit vector in the same direction. So as per our Coulomb's law, I can write the mutual force between this elementary charge dq and q0, or the force experienced by q0 due to this elementary charge dq is df is equal to 1 by 4 pi epsilon 0 Q0 into dq divided by r square r cap. Now I am considering surface charge distribution, so I need to consider surface charge density. Surface charge density is denoted by sigma, that is actually charge per unit surface area, dq ds. So from this I can easily write dq is equal to sigma ds. Therefore I may write it as 1 by 4 pi epsilon 0 Q0 sigma ds by r square into r cap. Therefore, the force experienced by this Q0 charge due to the entire surface charge distribution can be written as 1 by 4 pi epsilon 0 Q0. Now I am considering integration over the entire surface sigma ds by r square into r cap. Or if you want to find out the electric field at this point due to this entire charge distribution, I can write E is equal to F by Q0, that is equal to 1 by 4 pi epsilon 0 integration over S sigma ds by r square r cap. So these are the expressions of force and electric field due to a surface charge distribution. We may also consider volume charge distribution. For that, I need to consider a volume, charge is distributed throughout the entire volume. Let this volume be represented by V. I need to consider a small element dV within this volume, and this dV contains dq amount of charge. I want to find out the force experienced by Q0, which is at a distance r due to this volume element dV. I also consider unit vector r cap in this direction. So now I can write df is equal to 1 by 4 pi epsilon 0 Q0 dq by r square r cap. So as before, I may consider volume charge density. This is denoted by rho. Rho is equal to dq dv, charge per unit volume. So if you now substitute this, I will get it as 1 by 4 pi epsilon 0 Q0 rho dv by r square into r cap. So finally, the total force experienced by Q0 charge due to this entire volume distribution of charge is 1 by 4 pi epsilon 0 Q0 integration taking place over the entire volume rho dV by r square into r cap. And as before, if you consider electric field at this point, due to this entire volume distribution of charge, I can write it as F by Q0, that is equal to 1 by 4 pi epsilon 0 integration taking place over the entire volume rho dV by r square into r cap. Okay, so this is how we can obtain expressions for force and electric field due to linear charge distribution, surface charge distribution and volume charge distribution. Thank you.